AP Calculus, Calculus BC, Lesson 4.3, Derivatives of Inverse Trig Functions. Complicated stuff, lots going on. Let's back up. What do we remember about all these arc functions? For example, if this is sine, how do we graph the inverse of sine? And some people remember, oh, it's a reflection through the line y equals x, which is good. So instead of doing that, it does this. But it's not a function if we do it that way. So for arc sine, we limit the domain to this. And you can see this on your calculator. I've put in sine to the negative first, and I've graphed it. It just gives us the first chunk, and you can actually always pull it off of there if for some reason you need it. The domain is from -1 inclusive to 1, and the range is from -pi/2 to pi/2. However, it's only differentiable up to -1, not including -1, because that would be an endpoint. So these come in surprisingly handy. And the question is, how do we find the derivative? And just real quick, for arc cosine, we'll go with something like that. Domain again is from -1 to 1. Range is from negative. I'm not so sure about that now that I look at it. Struggling, so I just showed you how to fix that problem. Might as well do it myself. Graph it. Yeah, knew I was doing that wrong. So it goes like this, which I may have just graphed, I can't remember. The range goes from 0 to pi. And then arc tangent something like this. Domain is all reals. Range is from -pi/2, and this is not inclusive because those are asymptotes, to pi/2. So these are things to keep in mind when you're working with the arc functions. So let's derive the derivative of arc sine. I will write arc sine like this on a regular basis. You should try to avoid it. I do it because the test does it. You should write it as y equals arc sine of x. Because sine to the negative first, you might think you can use the power rule to derive it, and you can't. So we rewrite it, and we say that means that sine of y equals x. And we draw a triangle for this problem. Sine of y, we'll put y here, equals x, that's opposite over hypotenuse, which looks a lot like it's 1. We do a little math, a squared, b squared, c squared. Back it out, we get 1 minus x squared. We do this implicitly, so d dx is cosine of y dy dx equals 1. dy dx equals 1 over cosine of y, which according to this is 1 over square root of 1 minus x squared. You still have to watch out for the chain rule. If x is a differentiable function, then you'll have to mess with that. Well, let's show you how it works. So take d dx, you go 1 over square root of 1 minus, and this is x squared squared equals 1 over square root of 1 minus x to the 4th. done. We make a point of saying that x, absolute value of x has to be less than 1 here, because if it was greater, we'd have a negative in the radical, and that would not work. It also can't be 1 itself, so because it would cause a 0 at the bottom of the fraction. Pardon me, that's coming up later. So it's just something to keep in mind. That's why I started with domain and range and all that. So tangent and secant, well, what happened to cosine? You don't have to worry about it. Tangent, now I'll write it all out. Y equals arctan of x, tangent of y equals x. Y, x, 1 plus x squared. Square root. 1 implicit differentiation. Secant squared y dy dx equals 1. Dy dx equals 1 over secant squared, or just cosine squared of y. Cosine squared of y is 1 over squared, the hypotenuse squared. One over 1 plus x squared. No need to put a limit on that. X can really be anything, which is not unusual for tangent. And then for secant, again, what happens to cosine, we'll show you. Y equals arc secant of x. Secant of x equals secant of y equals x. So that would mean x over 1, assuming this is y, and this would be the square root of x squared minus 1. Implicit differentiation. Secant of x, tangent of y, tangent of y equals, goodness gracious, dy dx equals 1. Dy dx equals, again, divided by secant, like multiplying cosine over tangent. Cosine of y is 1 over x. Tangent is opposite. X squared minus 1 over adjacent, which is just 1. So we're done. And we have to put an absolute value around the x. I actually leave that as an example. There's lots of different reasons why we have to do it. Long story short, if you look at the curve of secant, it's always positive. So this just has to be a positive curve. Yeah, I wish I had a better answer than that, but I'll have to do for now. So, what's the velocity of the particle when t equals 16? If it's moving at this pace, so we say velocity is x prime equals 1 over 1 plus root t squared equals 1 over, no, I'm not going to be that dumb, almost, but not, times the inside, 1 over 2 root t equals 1 over 2 root t, 1 plus t, do it at t equals 16, and we get 1 over 2 times root 16, 1 plus 16 equals 1 over 136. Yeah, 8 times 17. Secant, which is written wrong, I'm going to fix it right now, should have a I just made quite a mess of this. And parentheses 5x to the fourth. It's a lot harder doing this without a keyboard than I thought it would be. Good. So, secant, I like to call the hard one, equals 1 over 5x to the fourth square root of 25x to the eighth minus 1 times 4 times 5x to the third. 5's cancel, they're just numbers. We're left with just x, and we need to keep it inside of our absolute value. Actually, we don't, because it would have been positive, and if that's negative, it's negative. If not, it's not. 25. Fix that in a moment. 4. 25x to the eighth minus 1. Like I said, pretty nasty looking little problems. Take some time. So I'm jumping ahead a little bit. Down here, I wrote them all up. And do the cofunction properties. Or if you want to draw your triangles and go for it, you'll get the same answer. Our cosine is negative arc sine. Our cotangent is negative arctangent. And our cosecant is negative secant. So you no longer have to derive anymore. You just run with those. And here's an example for cotangent. So the derivative with respect to x of cotangent is just negative tangent, 1 plus x squared. No extra chain rule I have to worry about. At x equals negative 1, negative 1 over 1 plus 1 equals negative 1 half. That is the slope. And now, if we want to find the point, we have to go and plug it back in, which is a hassle. So we put it in y equals cotangent to the negative first, negative 1. Where does cotangent equal negative 1? In the second and fourth quadrants. Tangent only works in the fourth quadrant. So we look at, my apologies, it's the arc function, so we're good to go with anything at 3 pi over 4. Cotangent. What a hassle. So then we get back to y equals negative 1 half x plus 1 minus plus 3 pi over 4. And we can finish that off. Y equals negative 1 half x minus 1 half plus 3 pi over 4. Now, last little thing, where's the button in calculator for cotangent to the negative first? secant negative first, cosecant negative first. Well, they don't exist. So we have some tricks since we're talking inverses here. Secant, write these down, question mark. Secant to the negative first equals cosine of 1 over x. And cosecant to the negative first of x equals sine to the negative first of 1 over x. So that's what I'm talking about here. However, cotangent has to be that, because otherwise we're gonna cause some problems. If you graph it, you will see that it breaks up. You want a curve that doesn't happen to. So just in case you ever wanted to graph them on your calculator, there they are. That's a ton of information and presented fairly poorly, if I do say so myself, but happy mathing.